So P12.2, properties of waves. So if you see here, we've got a wave. This part of the wave is called the peak, that's the highest point. This point of the wave is called the trough, that's the lowest point. And if you imagine that rope that we were talking about in the previous lesson going up and down, if you looked at it, there'd be a bit in that rope that wouldn't be moving. We call that zero, that's like zero displacement. And the distance between a peak and the zero displacement is known as the amplitude, and that should be exactly the same as the point of the zero displacement and the trough. Here they should be the same. And then if you look, you see the distance between the two peaks or the two troughs, and that distance will be the same. And the distance between either two peaks or two troughs is known as the wavelength. And if you remember from your speed equals distance divided by time equation, we can turn that into wave speed equals distance divided by time, where the distance is one wavelength. So how long does it take to do one wavelength? That will give you the speed. So you need to know how long it took for that one wavelength to pass. If instead of writing it that way, you can write it out a different way. So the frequency is the number of wavelengths per second. So what you in a certain number of seconds. So how many wavelengths in a certain number of seconds? That'll give you the frequency. And if you want one wavelength in however long that might take, that will give you the frequency. So then you can replace this t here with the 1 over t there to give you this wave speed equals lambda f, where all I've done is substitute in for 1 over t. I've just substituted in frequency, and the units for frequency are hertz, and that is known as the wave equation. Speed of the wave is equal to the wavelength times by the frequency, and all the frequency is how long it takes for one wave to pass.